The basic principles of the magnetic drive pump. Magnetic drive seal-less pumps, originally pioneered by HMD Contro, have long been used to pump many types of liquid, including those that require safe and secure handling, without the added cost and complexity of mechanical seals and their associated support systems. This short video explains how this is achieved. The principle of operation for a magnetic drive pump can be best understood by building the pump up, component by component. Firstly is the pump casing, consisting of the suction and discharge flanges and the casing volute. Inside the casing sits the impeller. Rotation of the impeller imparts energy to the liquid, causing the pump to operate. The impeller is supported by the internal pump shaft and shaft sleeves. The shaft is supported by the bush holder, consisting of a rigid holder and bushes or bearings which run against the shaft sleeves. Completing the inner rotor assembly is the inner magnetic ring. This is a ring of coaxially arranged outward-facing permanent magnets, which are fully encapsulated with a resistant metallic sheathing. The final component in the primary liquid contact assembly is the containment shell. This component is statically sealed with a gasket against the casing. The containment shell is usually manufactured from a high-strength, non-magnetic, corrosion-resistant alloy. Outside of the primary pressure boundary is a second outer magnetic ring with magnets that face inwards. The outer magnetic ring is located in the coupling housing, which is connected to the external bearing assembly. When the pump is filled or primed, it can be seen how the liquid is completely contained without the use of any dynamic seals. The principle of operation is very simple. The magnets in the outer and inner magnet rings are attracted to each other. So, as the electric motor rotates the outer ring, the inner ring rotates at the same speed, thus rotating the impeller and causing liquid to be pumped. To help understand how the magnetic coupling works, this animation views the coupling axially. The containment shell, shown in green, is positioned between the two attracting magnetic rings, and will be subjected to the rotating magnetic circuits as the outer and inner magnetic rings rotate. For strength and temperature resistance, the containment shell is usually manufactured in a metallic material, which is electrically conductive. It is this property and the rotating magnetic circuits that causes eddy currents to be inducted in the containment shell. These induction losses manifest themselves as heat and have to be accounted for when selecting the pump. It is important to understand that a small portion of the pumped liquid is also used to cool the magnetic coupling and lubricate the internal bearings. The pump uses the pressure generated by the impeller to feed a small amount of pumped product into the bush holder. Here, the flow splits. A small portion of the flow lubricates the internal plane bearings and returns to the pump casing volute. However, the majority of the flow enters the holes in the pump shaft and travels to the rear of the pump, where it splits radially and flows along the annulus between inner magnetic ring and the containment shell. As already mentioned, the metallic containment shell has associated losses which need to be cooled, and it is this internal flow that provides this cooling. After the flow has traveled over the inner magnetic ring, it then rejoins the bulk flow in the casing volute via the return feed hole behind the rear of the impeller. It is important to understand the impact of circulating the pumped liquid in the internal feed system. As the liquid is circulated, its pressure drops and temperature increases, and for safe and reliable operation, the liquid needs to remain stable at all times. If a magnetic drive pump is properly applied and operated, it will provide many years of problem-free operation. However, failures occasionally occur, usually as a result of process system upset or operational error. Many of the mechanisms that cause a sealless pump to fail prematurely result in the breakdown of the internal flow system and the subsequent presence of vapor. This is problematic, as vapor will not provide adequate cooling for the containment shell and lubrication for the internal bearings. Some such conditions can be detected by traditional instrumentation. However, these instruments tend to detect secondary effects and not the primary cause. The benefits of a magnetic drive pump are as follows. No leakage of product. No dynamic seal or seal support system. Complete fluid containment. Zero emissions. Cost-effective installation. Improved operator safety. Protection of the environment. Please contact Sundyne HMD Contro for further details. HMD Contro.